In the last part of the program, we looked at the operation of two different kinds of voltage regulators. Now we'll take a more practical look at voltage regulators. One of the most common types of voltage regulators being installed on overhead feeders today is the single-phase step regulator. In this part of the program, we'll take a look at the main parts of a step regulator and one way that it can be installed. We'll also watch as a crewman troubleshoots a faulty regulator by performing a visual inspection. As with any type of equipment or work, the details of the job and the procedures to follow can change depending on your company's equipment and policies. The job performed in this part of the program is intended as an example only. Be sure to follow your company's guidelines. Let's begin by taking a look at a single-phase step voltage regulator and see how it is installed in this system. The tank of the regulator has 3 bushings on its top, one for the connection to the line, one to the load, and one to the pole ground. Surge arresters are connected to the line and load bushings. This dial, called the position indicator, is mounted on the tank so that it can be viewed from below. The dial has a scale, which has a 0 or neutral position in its center. Additionally, there are 32 marks indicating the 16 steps above and below the 0. The pointer indicates the present tap position of the regulator. In addition, there are 2 drag hands, which indicate the highest and lowest tap positions that the regulator has moved to since the drag hands were reset. In the tank, oil is used as an arc extinguishing medium. An oil level gauge is located on the tank of the regulator so that the level of the oil can be checked easily. This voltage regulator has a solid-state control mechanism mounted in a metal box lower on the pole. It is permanently attached to the regulator by a control cable. When the regulator is changed out, the control mechanism and cable are changed at the same time. The control mechanism permits the voltage regulator to respond automatically to changes in line voltage. The control mechanism can also be used to operate the regulator manually. The mechanism is powered by a fused 120-volt source. Here, the voltage regulators for each phase have been mounted on separate poles. The phase is broken by inline insulators at the pole, and the regulator is connected to each side of the phase through a pair of permanently mounted disconnect switches and a bypass switch. In this case, the switches are mounted on a common base. However, other methods of connecting a regulator to the system may be used. Normally, the disconnect switches are closed and the bypass switch is open. This feeds power from the line side down through the voltage regulator and then out to the load side. When the regulator is in the neutral or 0 position, the unit can be taken offline by closing the bypass switch and opening both disconnect switches. Care must be exercised to make sure that the regulator is in neutral before bypassing. If the regulator is not in the neutral position, it would cause a short circuit and a danger of arcing due to the difference in the voltage between the line and load sides. This could cause personal injury and equipment damage. Now that we've seen one way that a voltage regulator can be connected to an overhead feeder, let's watch as a crew responds to a customer report of a voltage problem. In order to narrow down the possible causes of the problem, the voltage regulators will be inspected for any signs of an obvious problem. Beginning at one regulator, the lineman maneuvers into position to make a visual inspection of the jumpers and switches. He is looking for any signs of heat damage or corrosion. Moving on to the tank and bushings of the regulator, the lineman checks for any signs of damage that would affect its performance, such as broken bushings or an obvious oil leak. He also checks the level of the oil at the oil gauge. A low oil level may indicate a small leak over a period of time. A low oil level could cause heat damage to the internal mechanism of the regulator. When he looks at the position indicator, he notes that this regulator has limiting tabs on both the raise and lower side of the dial, which prevent the movement beyond the 8th step. This allows the regulator to vary the line voltage by a maximum of 5%. He notes the positions of the needle and the drag hands on the position indicator. The positions of the needle and the drag hands will be compared with the other regulators to see if one unit is obviously malfunctioning. Next, the lineman checks the control cable, its connections to the tank, and the control mechanism for damage. The control mechanism is checked to make sure it is still intact, and a voltage reading is taken to make sure that the control mechanism is still energized. Once the first regulator has been thoroughly checked, the lineman moves on to the second and the third. Inspecting the third regulator, he notes that the needle shows that the regulator is in its full boost tap position. This is a much higher position than on the other two regulators. Further testing indicates that the voltage regulator is locked in that tap position and can't be changed manually. Now that he is certain that the third unit is malfunctioning, the lineman reports the unit to the proper authorities.